displacement. You already know what is displacement, right? So when a force acts on an object and the object shows displacement, the force has done work on that object. Okay, so if a object moves from one place to another, that means that because of the force, that object has done a work, right? Getting the point?
Yes, ma'am.
And what is the formula for work? It is force multiplied by displacement, which is F multiplied by S. S is represented by displacement. Remember, for doing work, energy is required, right? If you want to do work, energy is required. So in animal, energy is supplied by food they eat. In machine, energy is supplied by the fuel. Animals include us as well, right? In human beings also, like whatever food we eat, through that we get energy. So this is your work. Clear?
Yes, ma'am.
Not much more work in spite of working hard. See, everyone reading, writing, drawing, thinking, and analyzing are all energy consuming. But in scientific manner, no work is done in above cases. Okay. See, in grammar, basically, if you are sleeping, that is also a verb, right? Verb. But in science, we are not talking about verb. We are talking about work, right? So if you are reading, writing, drawing, thinking, and analyzing, though reading also takes place, you need energy. Writing, you need. Drawing, you need. Thinking, you need energy, right? But still, you are not moving from one place to another. So that means no work. So they all are not a work. Clear?
Yes, ma'am.
Okay, so in scientific term, they are not work, though they are verb. In English grammar, when we do this, we study a verb means if you are even sleeping, that is also a verb, right? You are sleeping. What you are doing? You are sleeping, like this. But in scientific term, what is verb? When one object shows displacement, that is the verb. That is the work. Okay. Hmm. After that, work is said to be done when. Now, ma'am, as you told me, if you are reading, writing, it's not a work. So why when I will say that work is done? So see, a moving object comes to rest. For example, you were moving, you were standing here, and from here you come here, right? So that is also work. An object at rest starts moving. I was standing and suddenly I started moving. That is also a work. Velocity of the object changes. For example, earlier I was moving slowly, slowly, slowly. Now I suddenly increased my speed. So my velocity increases. That means work is done. Shape of the object changes, right? Earlier I was sleeping, right? Now I stand up. I stood up, right? So my shape changed. Earlier I was lying. Earlier I was uh, lying and now I'm standing. So again, it's a work done. Clear?
Yes, ma'am.
Okay. So
Yes,
first,
ma'am.
okay, you will start making notes from here. Just write chapter 11, work and energy. Okay, work. Then we'll do the next one.
Ma'am, can you please scroll down? Ma'am, can you please scroll down?
Okay, both of you done?
Yes, ma'am.
Done, ma'am.
Both of you done? Okay. Now, next topic is this. Scientific conception of work. So scientific conception of work is done when force is applied on a body and when that force produces motion under its influence. So according to scientific conception, like there is a concept in science that if work will only be done when force will be applied, and because of that force motion will take place, right? So only that is the scientific concept of work. And what are the conditions for work to done? First, force should be applied on the body and body should be displaced. Okay, these are the two conditions. If these two conditions are not being fulfilled, no work will take place. Next is work done by a fixed force, right? So see, work done in moving a body is equals to the product of force and displacement of the body in the direction of force. Very, very important. This direction of force is very much important. For example, this is the object, you like from this place this object shifted this place, right? And somewhere you have to apply force in this direction also, right? So where, like in which direction you are keeping, like putting the force, that is known as this. Okay, work equals to force multiplied by displacement. Again, work is a, remember, very important, work is a scalar quantity. Okay, you will now write it from here.
Ma'am, can you Done, ma'am.
Okay. Done. Jaslin, you are done. Okay. Now, unit of work. Right, ma'am? What is the unit of work? Unit of work is Newton meter or joule. Okay. So you can write Newton meter or you can simply write joule. Okay. Then after this, let's just understand one by one what is joule. So when sometimes they ask you to tell us what is joule, right? So when a force of 1 Newton moves a body through a distance of 1 meter, very, very important. This is 1 joule. Okay. When force of 1 Newton moves a body for 1 meter, you are applying 1 Newton force because force is always measured in Newton. And 1 meter is being displaced, is the distance, right? Then the work done is known as 1 joule. Clear? So 1 Newton force is applied, 1 meter you shifted, and that is known as 1 joule of work is done. Clear?
Yes, ma'am.
Okay. Now 1 joule equals to 1 Newton multiplied by 1 meter. That means 1 joule equals to 1 Nm. Clear?
Yes, ma'am.
Okay. Now after that, next thing is factor of work done. Like, okay, what are the factors that like on which work done is depend? The amount of work done depends on the following factor. First, magnitude of force. Greater the force, greater the amount of work or vice versa. So magnitude of force. Magnitude means power. So if greater will be the force, greater will be the work done, work, right? And if lesser the force, less will be the work. For example, there is an object, right? If you are applying more force, you will shift that object from, you can say, to a long distance. But if you are applying less force, then you cannot shift it to longer place, like a good distance. Now second is displacement. Greater the displacement, greater is the amount of work done, and vice versa. Lesser the displacement, less will be the work done, right? Of course, for example, initial position and final position, final position. If the distance between them is less, that means less work is being done. If more, the distance between initial and the final position is more, that means more work has been done. Clear?
Yes, ma'am.
Okay. So you will first write this unit of work. Unit of work is this. Then you will write this joule. 1 joule. This is not joule, this is 1 joule. Okay, first write this.
Ma'am, can you please scroll down? Done, ma'am. Ma'am, can you please scroll down?
Justly, you are also done till here.
Yes, ma'am.
Okay. Now let's just start with the next topic, which is negative, positive, and zero work. Okay. So work done by a force can be positive, negative, or zero. Right? It can be three. So when it will be positive, work done is positive when force act in direction of motion of the body. For example, if you are moving in this direction and forces are also applied in this direction, that is your positive work. Okay, you will not write this. Okay. Then over here, this should be equals to 0 degree. That means angle between direction of force applied and the motion of the body should be 0. Clear? Then negative force, a negative work done is negative when the force act opposite. For example, you are moving here and over here I'm applying the force. So this is your negative. Over here, this your angle is basically 180 degree. Okay, because you can see it's a straight line, so 180 degree, right? And zero work done is zero when a force act at right angle to the direction of motion. Direction of motion of the body. You will add over here, okay? It's misprinted. Motion of body, MOB. Clear? Girls, clear?
Yes, ma'am.
Okay, write it down.
Done, ma'am. Done, ma'am.
Okay, both of you done?
Yes, ma'am.
Okay. Now, coming to energy. So, ma'am, what is energy? The capacity of doing a work is known as energy. So, if you have the capacity to do something, that is your energy. And also, the amount of energy posed by a body is equal to the amount of work. If you have good energy, you will work good. If you don't have energy, then you will not work in a good way, right? So, the amount of energy possessed by the body is equal to the amount of work it can do. Working body loses energy. Body on which work is done gains energy. Remember, very, very important line. See, for example, you are pushing a object, right? So you are a working body, right? So that means you will lose your energy, right? But the object which is moving, that object will get energy, right? So working body always loses energy, but body on which work is being done, that gains energy. Clear? They ask you in one marker. Clear?
Yes, ma'am.
Okay, now sources of energy. Sun is the biggest source of energy. Most of the energy sources, most of the energy sources are derived from the sun. Some energy is received from nucleus of atom, interior of the earth, and tides. Okay, so some of the energy you receive from nucleus of the atom, interior of the earth, as well as from the tides. Clear? And next, energy is a scalar quantity. Very, very important. Wherever you are getting that this is vector quantity, this is scalar quantity, you have to remember because they ask you in one marker whether energy is a scalar quantity or vector quantity. So energy is a scalar quantity. Then there are different forms of energy: kinetic energy, potential energy, chemical energy, heat energy, electrical energy, light energy, sound energy, and nuclear energy. Clear?
Yes, ma'am.
Okay.
Ma'am, can you please scroll down? Ma'am, can you please scroll down?
Okay, Jaslyn, you are also done. Jaslyn, yes or no? You are not audible. You can type.
Done, ma'am.
Okay. Now, mechanical energy. right? So what is mechanical energy? So sum of kinetic energy and potential energy of a body is called mechanical energy. So when you will add kinetic energy and potential energy, you will form mechanical energy. And the energy posed by a body on account of its motion or position is called a mechanical energy. So you have two definitions. See, whatever energy your body is posing in relation to its motion or position, that is your mechanical energy. Clear? And okay, so you can quickly write it down.